Assalamualaikum, my name is Fatin Farhana and I'm going to explain further about the material selection for frying pans. The material used for frying pans are aluminium, thermoplastic polymer, Revex, ceramic coating and diamond coating. First is aluminium. Aluminium is the main material for manufacturing of frying pans. One of the reasons because it is an excellent conductor of heat. It enables heat to spread quickly. Furthermore, it is lightweight metal, about 1/3 the weight of the steel, so it is easy to handle. Besides, it does not rust. Second is the thermoplastic polymer. It's been used in the handle of the frying pan to make it easier for the user to handle the pan while the pan are hot on the stove. The material itself is lightweight, corrosion resistant, durable, and have high impact resistance. However, thermoplastic are not as strong or resistant to heat as that of metal. Third is rivet, unthreaded headed pin used to join two or more parts by passing pin through holes in parts and forming second head in the pin on opposite side. Next is diamond coating, used in the interior part for frying pans. It uses non-stick coating made with diamond because it helps to distribute heat evenly across the surface of the pan. It also allows the pan to brown food and easily wash it away with warm soapy water after done cooking. Next, it has intrinsic non-stick properties. Next is ceramic coating, used for exterior surface of frying pans. It is much safer than earlier non-stick pans because they are made without potentially toxic chemicals such as perfluorooctanoic acid, known as PFOA. The non-stick surface of pan that use ceramic-based nanotechnology is said to be stable on exposure to high heat and resistant to flaking.
And the process is divided into two: hot rolling process and stamping metal process. The hot rolling process, the first premium quality aluminium are melt into liquid state at around 660 degrees Celsius and then filter to remove contaminants. The liquid aluminium flow into vertical rectangular molds. A jacket of water around the molds cools the aluminium to transform it from a liquid state to a solid state. A crane extracts the coarse slabs and then heating at a heating chamber to soften the slabs. This will allow the metal to be shaped in forms. A saw slices the slabs in two and trims the end of a conveyor. Repeatedly fed the shorter slabs to the heated rollers. Fluids at the side maintain the width while the roller compress the aluminium, taking the thickness down to about half a centimeter. They also elongate the slab substantially. Second, the stamping metal process. In the process, the aluminium sheets are pressed using the Isotan's powerful press machine. It will cut out a round blank arc aluminium sheet as a straighting shape. Then clean off any debris from the metal surfacing around. Even the minute chart getting under the press will damage the metal. After that, the blank are put into a 200 tons press containing a forming tool. The powerful pressure forces around the metal and then punches out the shape of the finished frying pans.
3.
And the machining. Machining is a pickling process. This is the process where the aluminium pans are cleaned and then treated with sodium hydroxide. This opens the pore of the metals to allow an enamel coating to take the outside and the non-stick finish to adhere the inside. After that, it will inspect the pans and places them outside down on a spray fixture.
Assalamualaikum, my name is Marlisa, so I'm going to explain about coating and joining process. Before pans are coated, it will be put in the sand blasting chamber to improve adhesion. The space is tight fit to shield the inside from the enamel spray that comes next. We prepare up to 5 proprietary coating formulations for each frying pan model, and each have a dozen of chemicals and a tiny diamond particles. Lemon can increase the durability in heat, conductivity, and also make the food less likely to stick on the surface of the pan. The spinning ensures even coverage as the coating adheres to the hot pan. Next, we go through a furnace to adhere the coating in 560 degrees Celsius. Special primer is applied to the interior surface to make the non-stick coating adhere to the pan. It then applies the non-stick coating and send to the furnace again to cure the non-stick finish at around 425 degrees Celsius. Next is joining by riveting process. Once the pans are cooled, a robot transfers them to a lathe where the pan's bottom are trimmed accurately to be a perfectly flat base. This leaves a clean level surface on the bottom of the pan and ensure the stability of the pan on the cooktop. After that, a suctioning robot moves the frying pan to the next station where the holes are punched in a precise location on the side of the pan using a hydraulic punch press. The workers will slide the pins into the holes and slots them through a holes in the handle fitting. Using a ram, a worker will flatten the pin to rivet the polymer handle to the pan.
I'm going to be explaining about the processing of polymer, which is done through thermoplastic injection molding. Thermoplastic injection molding process begins by adding pelletized material to a hopper. The material is gravity fed into a heated barrel and screwed. Rotation of the screw results in shearing action on the raw pellets, causing them to melt. The screw rotation also pushes the molten plastic forward in the heated toward the mold. The material is then injected into the closed mold at high pressure through a runner system to fill all the cavities. The mold is clamped shut under enough force to keep the mold halves together while the molten plastic is flowing. A hot runner system is used where the plastic in the runner stays molten so no material is wasted. When the mold cavities are filled, the part cools until rigid enough to be ejected. Part cooling within the mold is accomplished through water lines cut into the mold. At the completion of the cooling cycle, the mold opens and the part are ejected for part removal. Next, I'm going to be explaining about the surfacing, dimensional, and specification. Our frying pan is a flat bottom pan that can be used for frying, searing, and browning food. It is typically 240 mm in diameter with relatively high side 52 mm, flattened and rounded, without any sharp edges. Next, it also has a long practical set of handles, which is 170 mm, and it is used to push food into a dish or plate. Our products are resistant to scratches and corrosion, have high quality aluminum body, has excellent and consistent heat distribution, smooth and non-stick surface for cooking. The technical drawing is done with a few views, which are the top, bottom and side view of the pan and also the handle with the dimension to make our drawing complete. That's all. Thank you.
Hello, my name is Dara Esman. I'm from BMMV 2/1. Today I'm going to explain about the result for the assignment. So for our assignment, we choose frying pan as our product. Our frying pan is a flat bottom pan which is used for frying, searing, and browning foods. So I'm going to explain about the diameter for the frying pan. Our frying pan has a outer diameter of 240 mm and an inner diameter of 224 mm. It has a height of 52 mm with less flare and more vertical sides. So the less flare and vertical side makes the food slide easily into the dish or into the plate. So now I'm gonna talk about the handle of our frying pan. So the length of our frying pan handle is around 170 millimeter. It is made out of plastic polymers. So the reason why we choose this material is because plastic polymers is a bad conductor of heat, which make it more safer for us to hold the handle when we are cooking. Our product is resistant to scratch and corrosion. So our product is made out of aluminum. The reason why we choose aluminum because it is an excellent and consistent heat distribution. It also has a smooth and non-sticky surface, which it makes more easier for our daily cooking. So that's all from me. Thank you.